So in the given problem, he has given a single phase full converter which is connected to 230 volts 50 hertz supply with a load of 10 ohms, and it is drawing a reactive power of 200 watts from the supply. He is asking what is the firing angle of the converter during that condition. So here the load is a purely resistive load, right? So the output current is nothing but V0 by R, or I can say V input by R. No, yes, V0 by R. We'll see how the plots. So this is a supply voltage, and if I fire at an angle of alpha, so somewhere else here, and I have to fire at pi plus alpha also. So the output expression will be, the output voltage expression will be something looks like this. Like this. So this is alpha, this is pi plus alpha, this is pi, and this is 2 pi. Now, so this is a supply voltage and this is a output voltage. So if I want the output current, so this is nothing but by R. So this will become Vm by R, because this is Vm. Now the reactive power drawing from the supply, that is nothing but the input RMS into input voltage RMS into input current RMS into sin phi is equal to 200 watt, where cos phi is a power factor. So since it is a reactive power, we have to multiply with sin phi. Of course, in a full converter, phi equal to alpha. Okay. Now first of all, I have to find out the Fourier series of the output current. So for any waveform, you can represent in terms of Fourier series in terms of sine and cos omega t. For example, in this case, I can represent the input current, which is a function of t, or the fundamental input current, is equal to some a1 into cos of omega t plus b1 into sine of omega t. This is the Fourier expression for the input current, where a1 equal to 2 by 2 pi into, so here from alpha to pi, this is Vm by R into sin theta, this is apply, into cos theta plus pi plus alpha to 2 pi Vm by R sin theta into cos theta. So for B1, the same expression will come, but instead of cos theta, you will get sin theta. So first, if you simplify this, you will get Vm by 2 pi R into cos of 2 alpha minus 1. So similarly, B1, this is equal to 2 by 2 pi alpha 2 pi Vm by R sin theta into sin theta into d of omega t plus pi plus alpha to 2 pi Vm by sin theta into sin theta into d of omega t. If you simplify this, you will get Vm by 2 pi R into 2 into pi minus alpha plus sin 2 alpha. So this is A1 and this is B1. Now this I1 equal to A1 cos omega t plus B1 sin omega t, it can be represented as square root of A1 square plus B1 square into sin of omega t plus tan inverse of A1 by B1. This is a theta or phi. Okay, I'll represent with phi. So phi equal to tan inverse of A1 by B1. So from this, tan phi equal to A1 by B1. So sin phi equal to A1 by square root of A1 square plus B1 square. Now the expression is V1 input RMS, that is given as a 230 volts, I1 input RMS. So actually this is a peak value. So RMS means A1 square plus B1 square divided by root 2 into V1 RMS, supply RMS, supply current RMS, supply voltage RMS into sin phi. Sin phi is nothing but this one, A1 by square root of A1 square plus B1 square equal to 200. So A1 square gets cancelled. So A1, what you substitute? Just substitute this whole value A1, Vm by 2 pi r into cos 2 alpha minus 1. You just substitute here. So if you substitute here, the whole expression contains only unknown, this is alpha, right? So if you substitute, you will get the value of alpha as 20.16. So I'll just calculations. The moment when you substituting Vm by 2 pi r into cos 2 alpha minus 1, so everything is known because the supply voltage is given. The supply voltage is given as 230 volts, right? So 230 into root 2 by 2 pi into 10, r is also given. So the only unknown is alpha, cos 2 alpha minus 1. Just substitute in this expression and then find out alpha. So you will get alpha value as 20.16.